And our final speaker today is Don Monn from Taiyo, America. Don has worked in the PCB industry for over 40 years and has specialized in solder mask, including production supervision for advanced circuits and technical service applications management for Lee Rennell and Sieber. He has served as sales manager for the Midwest and East Coast of the United States, as well as Canada and South America for Lee Rennell, Sieber, and Taiyo America. For the past several years, his responsibilities have included European sales management and OEM and new product management. Don's current role is sales manager for the Midwest United States and assisting Taiyo America in all aspects of the business growth in Europe. Now, Don usually wanders around the podium during his presentations, making life pretty difficult for me as the event photographer. So we'll have no such problems today because he'll be sat in his chair, I'm hoping. And we look forward to hearing your insights, Don, how we may finally capture this solder mask holy grail. So over to you, Don.
Good morning, everybody, or good afternoon. What I didn't know about doing these Zoom calls is none of you can see me right now, but because I have the podium, I can see all of you. And it's amazing. A couple people out in the West Coast are still in their jammies. And there is a couple guys in Europe with their feet on the desk drinking Pepsis right now. So good for you guys. Many of you had heard me talk about these topics before. We're going to go over a basic history and a trend. I believe most of you know where the trend is going, but some of the numbers and information might be useful. So we talk about solder mask. What have and what do people want from their solder mask? Well, since the beginning of time, they've always wanted improved registration. They've always wanted faster processing. They want to get more stuff done per hour. They want more robustness to final finishes. They want better OEM acceptance. They want a rainbow of colors, multiple colors, surface finishes. They want really good high reflectivity, color stability with white. And of course, they always want it cheaper. You know, who doesn't? We're humans. Give me it better, give me it cheaper. Understandable. So the history of and the trend of the solder mask, the progression was years and years ago, when many of us were younger, we had image screening. We did that for years. In the late 80s, we brought liquid photoimageable came into play. Much later after that was still photoimageable. We got into laser direct imaging, what we call LDI, laser direct. And that moved on to direct imaging, which is DI, which is laser diodes, LEDs. But where we're going to go, where we're going today, and where we're going to continue to go is to inkjet for a lot of great reasons. So image screening, years ago, you'd stretch a screen, you'd match that image to your circuit board, and you'd have a semi-automatic, as we have here on the right, or you'd have a guy pushing or pulling a squeegee, as we have on the left, trying to mimic the surface on that substrate. The results and or potential results with image screening is obviously you had registration issues. We had to have a piece of artwork to shoot the image onto the screen. We had bleeding because as your operator or your machine is running the squeegee across the mesh, you're getting solder mask deposited underneath your emulsion on the backside where you don't want it. We would get skips in between copper traces, high copper plating, circuitry running perpendicular to our squeegee stroke. We'd have exposed copper from skips or registration. And we'd also get uneven mass deposit because let's face it, if we're doing hand screening and you're pulling a squeegee, 18-inch squeegee over a 2-foot circuit board 8 hours a day, you tend to get tired towards the end of the day. So in the late 80s, we got introduced into LPI, liquid photoimageable. We used a curtain coat. There's a airless spray machine. There's a guy down there in the corner pushing a squeegee. Way over to the bottom left is a semi-automatic press. And then we also have a really nice piece of equipment, a circuit automation double-sided screening machine with a tunnel oven. This is a great setup and very popular and still running very well today. So your results and potential results with LPI is all of a sudden your registration issues pretty much went away, but we still had to have a piece of artwork. The difference is the artwork was no longer setting up our screen. Our artwork is now setting up the registration directly on the board. Our bleed issue went away because we're not image screening. Skips were still a potential problem. Exposed copper due to registration all but vanished. Our uneven mass deposit went away because we're using these quality circuit automation double-sided screeners. However, we did introduce another potential problem, which is the dreaded MIH. And as we all know, MIH is mask in hole. And even though we're running with LPI, we're still depending on a piece of artwork for success. And artwork, you have to buy the material, you have to expose the material, you have to develop the material, you have to maintain the material. The artwork is heat sensitive and humidity sensitive. So we moved on to solid state laser, and the laser was simply a way of exposing the board. It wasn't, your application is still the same, but we've got a new way to expose our image onto our circuit board. The results with the solid state laser, the registration issues, just like with LPI, are gone, but you notice a check mark now at artwork. We no longer use artwork. This was a breakthrough. This was amazing. Bleed is gone, skips are still possible, and this is why you buy a circuit automation double-sided screener, best possible coating. Exposed copper for registration is gone, uneven mass deposits gone. We still have the potential of the MIH. One thing really nice about the laser is that before lasers were really introduced for solder mask, the solder mask folks and the equipment folks got together and they discussed wavelengths. And circuit board manufacturers could, if they chose to, they could build a solder mask for a specific wavelength that these lasers run. And if you do that, you can have your dams looking kind of like this one here in the photo. The next step was the introduction to direct imaging, which is what we call DI. We still have a curtain coat, spray, screen print. We have multiple manufacturers of equipment. We have UV diodes, we have laser diodes, we have UV LEDs. A lot of the equipment have different wavelengths. They might have 2 different wavelengths. They might have 3. They might have 4. Different numbers, as low as 355, up as high as 405, anywhere in between. The potential results with direct imaging, just like before, registration issues, artwork, bleed, we don't need artwork, that is great. Uneven mass deposit, as long as you're using circuit automation, good stuff. MIH is still a potential. The issue with DI with all these different pieces of equipment is the discussions that were held before with the laser were not held with the DI equipment. So the solder mask people have been forced to make their solder mask work with all these different wavelengths, with all these different intensities, which is very difficult. And again, MIH is in red. MIH is a potential problem. It can be maintained. It isn't really a problem. It's something you have to be aware of in your processing. So what's trending today? Okay, so today LPI, liquid photo imageable, is going to DI. Things are going to DI. LDI is going to DI. And reason being is the DI pieces of equipment cost far less than the laser. They're much more prevalent. You have more uses for them. In North America today, 40% of the mass that's consumed is direct imaging. We no longer use artwork. Registration is much better today than it had been. And this is not a trend. This is not something we're guessing on. This is a measured and documented occurrence. We track this every day. What else is trending? Well, high temperature solder mask for the automotive industry and other high temperature applications. Dry film for packaging. This is an area of huge growth. Heat management options, very important for all of us. Copper plating for heat management, heat sinks, material setups. But what if somebody else could give you another option, something you could put on the surface or in a hole or both and move heat? These are things that people are wanting. A crack-resistant white ink for LED applications is something that is trending. It's not only trending, it's needed. Luckily, we have it. So what will continue trending? Inkjet solder mask is trending today, and it's going to continue trending. Why? Well, it's a fully additive process. If you look at all of our check marks, the registration issues are gone. The artwork, we don't need artwork. We're not going to have bleed. We're not going to have skips. We're not going to have exposed copper. We're not going to have uneven mask deposit. And we're not going to have mask in hole because we never put it in there in the first place, so we don't have to worry about getting it out. For those of you who listen to me speak at EIPC conferences in the past, I've always talked about doing things right the first time. Yield is the most important. You don't make money doing things twice. As we get on to doing things that are more important, as autonomous cars are coming into reality, do you want to supply circuit boards that are going to fail? Nobody wants to do that. Quality is more important than ever. So inkjet solder mask is going to continue to trend moving forward. So the typical process for LPI, we prepare the surface, the copper, we coat the board, we pick up the board, we have to tack dry it. We tack dry the board, we take the board, we expose the board. We take the board off of there, we develop the board. We take the board out of the developer, we cure the board. A process for inkjet is we prep the surface, we jet the mask onto the board, we cure the board. It's fewer steps, it's fewer handling, it's fully additive. Why wouldn't you want to go inkjet? Why wouldn't everybody investigate inkjet? So the conclusion, and this is where it gets fun, the advantages of inkjet printing, they're too numerous to ignore. Whether you're a circuit board manufacturer, an OEM, everybody needs the advantages. The PCB makers, OEMs will benefit from the trend. Board values are up. Yields are more important than ever. My favorite point on this whole presentation, the inkjet machine installations have doubled each of the last 2 years. If you take that analogy right there, and let's just say the number of installations, let's take North America, you can count the installations on 2 hands. If you double that for the next 4 years, well over 60% of the market will be doing inkjet. And if the right manufacturers are doing inkjet, now we're talking 80% of the volume being done by inkjet. We're prepared. I think the mask suppliers are prepared for this. I hope the equipment suppliers are prepared. Higher temperature masks are needed due to added heat. And again, it's not just the higher temperature mask, it's the options. Who doesn't like options? Options are needed. If you have options of putting something in the hole on the surface, even at the same time to move heat, that's an option. Options are good. Options for heat dissipation will benefit many. It'll benefit the people who supply the boards. It'll benefit the people using the boards. It'll benefit the consumers. So again, short and sweet. I think we all knew what was coming, but I think it was important to tell you that the trend is going to inkjet. It's not going to slow down. There's no reason for it to slow down. So anyway, thank you for your time. It was good seeing all you guys again.
Yeah, thanks so much, Don. That's very interesting. You know, we expected you to talk about inkjet, inkjet solder mask, and you did. So well done. We've come to the stage now of the Q&A. We still have a bit of time left, not so much, but so could I ask the speakers all to unmute and turn their cameras on, and we can see what questions we have.
I have a question from Jan Pedersen from Elmatica. He asks, I assume to Don Monn from Taiyo, what is the speed of an inkjet SM process compared to LDI?
Well, that's a great question. It's very equipment dependent. It depends how many heads they put on the piece of equipment. And obviously the more heads, the more dollars. So the initial pieces of equipment sold have a very low number of heads because I think people are feeling out the technology to see if it's viable, which is probably smart, before they invest on adding heads. But it's very dependent on how much money you want to spend.
Okay, thank you.